Okay. All right, so let's attempt this problem with the ratio test. Okay. So we're going to be looking at the limit as n tends towards infinity of a sub n plus 1. Now all of this is positive, so I'm going to leave off the absolute value signs. Divided by a sub n, which would equal, this would be n plus 1 factorial divided by, now, n plus 1 raised to the n plus 1, okay? And this would be an n factorial, and n to the n like that. Okay. So the first thing to do is to cancel out involving the factorials. I'm going to break this up a little bit, okay? So this would just become n plus 1, right? I'm going to leave this as n to the n power, and I'm going to call this n plus 1 raised to the n and then multiplied by n plus 1. So that's n plus 1 to the n plus 1. And so I'm just breaking off an n plus 1 onto this thing, okay? And so those can cancel each other out. All right, so I'm left with the limit as n tends towards infinity of n to the n divided by n plus 1 raised to the n power. Now, I'm a little stuck on this one. So what I'm going to do right now is I'm going to divide the top and the bottom by n to the nth power. Okay. And so what that's going to give us is going to equal the limit as n tends towards infinity. Okay, so this can be 1 divided by, right, so I could put all of this n plus 1 divided by n, all of this raised to the nth power, which would equal the limit as n tends towards infinity of 1 divided by 1 plus 1 divided by n, now raised to the nth power, and this would equal 1 divided by e, which is less than 1. Okay? And so, since this is less than 1, by the ratio test, the sum n equals 1 to infinity of n factorial divided by n to the nth power is absolutely convergent. Okay.